We're going to do the Decay of Abraham Lincoln lab, and you can download that from the document section. It'll say week 1, physical science, Decay of AB, something like that, under the document section. And then you'll have to actually print this one, because you're going to have to fill out a data table, and from the data table you'll make a graph that should mimic the decay of a radioactive element. And when you're finished, then you'll have to somehow get it back to my email address, which is right up here, same as all the teachers, just first initial, last name at ocamail.org. If you have some way to scan it in and send it to that's fine. Or you can take a picture of it and then just forward that to my email address. I guess I'm not worrying about that as much with your generation. That would be harder on my generation, trying to figure out how to get it to somewhere. But if you've got your sheet, the front page gives you an introduction to what you're doing. Congratulations on your new job, and I hope you get the promotion. And make sure you fill out that question on the front part. And then you're supposed to count to make sure that you have exactly 100 atoms of this new and strange element. And I have already done that, so we'll go ahead and get started with the decay and counting it up. It would be more exciting to watch 5 or 6 groups doing this in class rather than you watching one person do it, but everybody will have the same graph. Let's get started. Now, part of this you're just going to have to trust me, because you're not going to be able to read whether it has actually decayed or not, but there are 100 of the atoms in here, and probably too dark to show you, so you have to take my word for it. They are all Abe Lincolns at this point. But we'll do the first spill. Spread them out. The first time takes a lot longer than any of the others. And then I just have to separate them into 2 different piles. The ones that are still Abe Lincoln and the ones that have decayed into memorial. And I am finished with the ones that are memorials. I just want to keep the ones that are the Abe Lincolns. And at first it looks like there are more that are Abe Lincolns than what I would have expected. Memorials. All right, I just have to count these, put them into groups of 5. All right, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 55, 59 are still After one spill, I still have 59, so I filled that out on your data table. So when you get your data table downloaded, you will have that much of the table filled out. From here on, you're going to have to fill it out. I'll tell you what it is, but we're done with those memorials. We'll put the Abe Lincoln back into the scientific cup. Same thing again. Plenty of decay this time. Alright. Make sure there's no Abe's in there. 15, 20. That time, I'm going to write it down. I'll let you. After two spills, there are only 24 left. So 24 go back into the cup. Exactly 15. 15 after 3 spills. Okay, and so there are 9 after the 4th spill. There's only 3 after 5 spills. Only 1 after 6. 1 after 7. 1 after 8. 1 after 9. 1 after 10. And 0 after 11. So you'll have a total of 11 spills to get it down to 0. Now when you're finished with this, on the, whoops, it's on this paper, there are 2 questions. You need to graph it first, and on your graph, I have set up for you, I have labeled the axes already, and the first mark is made at time of 0, you had 100 of them. And then I can mark the second one after 1 spill, you had 59, which is going to be half a line below the 60, and you'll just continue down until at 11 you get to 0. And you will have actually a graph that is very close to what an actual graph of radioactive decay will look like. After you've done that, you'll make a smooth curve. It will not be a straight line. It will be a curve when you're finished, and then you'll answer the 2 questions. The first one, you just have to figure out what is the half-life. How many spills did it take on average to cut the number of Abe Lincolns in half? That one shouldn't be too difficult. The second one asks you when the radioactive sample was more dangerous, whether it's early in the process or late in the process. So it's not asking for a specific second, or spill. The time is in spills, but and it's going to be more dangerous when more are decaying. If there's very little decay, then it's pretty safe. But when lots of it is decaying, giving off lots of alpha, lots of beta, and especially dangerous, lots of gamma radiation. So it will be when there's the most decay. So looking at the graph, for those of you that are into graphing, and when you have the steepest slope, that will be where you have the most decay, and that will be the most dangerous part of it. And again, when you're finished, then I will need a picture of all 3 of those. The front one, make sure you put your name on it, although hopefully I can tell from the email that it comes from. The definition on the front, I will need your data table and your 2 questions, and then I'll also need the graph. Hopefully that makes sense and it helps you understand radioactive decay.